So we'll start with the cross-section study. A cross-sectional study is an observational study in which exposure and the disease are measured simultaneously at one point in time. So this is what is the difference with respect to the cohort study. There we had only exposure at the beginning, while in cross-sectional we have the exposure as well as the outcome. A cross-sectional study is an observational study in which exposure and the disease are measured simultaneously at one point in time. Okay, so cross-sectional mnemonic is current C for current status, R for rapid, O for one-time assessment, S for snapshot, and S for simultaneous measurement. Okay. So for examination, you should remember definition as a cross-section study measures exposure and disease at the same time. It's a snapshot. Okay. It will take the picture or image of the exposure and the disease at the same time. Okay. Why it is called a snapshot study? It's like a photograph. The photograph shows the who is exposed, who is diseased, and at the exact moment, but it will not tell you which came first, exposure or the disease. Okay, so this is just a snapshot, and this is the image which will show. So the snapshot or this study is taken at this particular point of time. So during this particular period, this is the picture. This is the study population in this time. The study population had a group with no disease and the group with disease, and then this no disease patients, you look for the factor which was present, or the exposure was present or the exposure was absent. Same thing in the disease group, exposure or the factor was present or the factor is absent. So this is a snapshot study. Okay, that is the cross-sectional study. So you have a target population. From the target population, you select the sample, you will measure the exposure as well as the disease at the same time. Okay, and you will divide this population or the sample into exposed and disease, exposed and non-disease, then non-exposed but disease, and non-exposed and non-disease. So that is how you will divide your sample. So key feature of the cross-section study is that unlike cohort study, where the cohort is measuring the exposure and following them up for over a period of time to develop the disease, while cross-sectional will measure the exposure as well as disease together. Okay, so the difference between the cross-sectional and cohort is that participants are in the baseline in the cohort will be disease-free. Here, diseased as well as non-diseased individuals will be there in the cross-sectional. The purpose for the cohort is the incidence calculation. Okay, why you require disease free? Because you want to calculate the incidence. In cross-sectional, you will get the prevalence because it includes the existing cases. Okay, so in cross-sectional, you will get the prevalence. Okay, disease is present at the start in the cross-sectional, it is not present in the cohort. Which will require a follow-up? Cohort will require a follow-up. Cross-sectional will not require a follow-up. The main measure here in the cohort is incidence. New cases are observed, while main measure in the cross-sectional is the prevalence. No new cases are required or observed. Okay, this prevalence will be given by the cross-sectional. Okay, incidence will be calculated by the cohort study, but not by the cross-section study. Okay, so what is the sample in the cross-section study? So in cohort study, only disease-free individuals, but in cross-section study, you get a disease plus non-disease individuals that is included in the sample. So therefore, disease is already present and prevalence can be measured in the cross-section. Okay, so cross-section study also called as prevalence study. This is also very frequently tested concept. Okay, so 2x2 table for the cross-sectional will be this is the disease and non-diseased. Okay, and here we will put exposed and unexposed. Okay, so this is the 2x2 table we are going to put as A, B, C, D. And what we can calculate in the cross-section study, can we get the incidence? We will not get the incidence. We will not get the relative risk in the cross-sectional. We will get the prevalence and the odds ratio. Okay, so what is odds ratio? Since incidence cannot be measured, we use odds ratio in the cross-section study. So odds is the number with event divided by number without the event. Okay, so formula for the odds ratio is odds of the disease in the exposed divided by odds of the disease in the unexposed. Okay, so odds of the disease in the exposed So here you calculate the odds for this as A upon B, and we calculate the odds for unexposed as a C upon D. Okay, and we divide odds of this divided by odds of this. Okay, while if you remember relative risk, what we calculated in the denominator, that is the incidence in the exposed divided by incidence among the unexposed. So there it was A divided by A plus B, C divided by C plus D. But here it is an odds. So we calculate A upon B divided by C upon D, giving AD into BC as a formula, which is also very frequently asked. Okay, so odds of the disease in the exposed divided by the odds of the disease in the exposed, that is the odds ratio. So 2 by 2 table, it will give you A upon B divided by C upon D equal to AD upon BC. Okay, now we will calculate this for this odds ratio for this. Okay, so what is the odds in the smoker? A divided by B. So 3 upon 1 is a 3. Okay, for non-smoker, 2 divided by 4. Okay, so 3 upon 1 divided by 2 upon 4. Okay, so our other is a into D divided by B into C. So 12 divided by 2 is the 6. Okay, so that is what is the odds ratio. So what is the interpretation of the odds ratio? The odds of the disease were odds ratio times as high in the exposed compared with the unexposed. So we will say the odds of hypertension was 6 times as high in smokers compared with the non-smoker. Okay, so that is what is the interpretation of the odds ratio. Here time is not measured, it is a snapshot. In cohort study, you follow them over a period of time, so you get the time in the denominator. So in cohort study interpretation, over 10 years is included. In cross-section study, there is no follow-up, no time component, therefore no mention of time in the cross-section study. Okay, so interpretation of the again odds ratio equal to 1 means no association. Odds more than 1 is a positive association. Odds less than 1 is a protective association. Okay. So null value for odds ratio is 1. Why 1? Because odds in the exposed equal to 2, odds in the unexposed, that means no association exists. Now, what does this cross-section study gives us? Cross-section study will give us prevalence. Okay, so prevalence measures existing cases of the disease at a specific point in time. Okay, so existing cases of disease at specific point in the time. So what is the formula for the prevalence? Suppose this is the 2 by 2 table. So what we have to do? We have to get the total diseased in the total population. Okay, so total disease will be A plus C. Okay, A plus C divided by whole population, that is A plus B plus C plus D. Okay, so prevalence equal to A plus C divided by A plus B plus C plus D. Okay, so if this is the 2 by 2 table which is given to you, the disease in the exposed group is 2 and disease in the unexposed group is 2. Okay, healthy in the exposed group is 1 and non-disease in the unexposed group is 4. So total population is 10 and total disease are 5. So 5 upon 10, that will be 50% will be your prevalence. Okay. Now we will see the odds ratio versus relative risk. Relative risk is calculated in the cohort study. Odds ratio, actually when we say about odds is a typical of case control, not of the cross-sectional. Okay, but it can be calculated. Okay, so odds ratio, if it is asked, then please select the case control. Okay, but here just understand the concept difference between the odds ratio and the relative risk. Okay, so the odds ratio is always further from the null value than the relative risk. Okay, now if you calculate the odds for the same population and if you calculate the relative risk for the same population, you will find the odds ratio is higher than the relative risk. Okay, because in relative risk, what you do? You do the A upon A plus B. So your denominator is higher in the relative risk. Okay, so the relative risk will be always lower than the odds ratio. For example, if you measure the relative risk, it will be 2.27, while odds ratio is come 6 for the same 2 by 2 table. That means odds ratio is larger. And why this happens? As the disease becomes more common, odds ratio will move further away from the relative risk. Okay. So rule of thumb is that when prevalence is less than 5%, in that particular case, odds ratio will approach the relative risk. But if the disease is more common, the prevalence is high, odds ratio will always be higher than the relative risk. Remember, only when prevalence of the disease is less than 5%, your odds ratio will be equal as a relative risk. Okay, but odds ratio typically calculated in the case control study. So for rare diseases, odds ratio is same as relative risk, and for common disease, odds ratio will never be same as relative risk. Okay, there will be large difference. Okay, so why do some cohort studies report odds ratio? Okay, some cohort studies can also report odds ratio, but cohort typically will give you the incidence. Okay, so this is mainly because of the logistic regression. Many statistical software packages automatically generate odds ratio instead of the risk ratio. Okay, so the incidence actually gives us the risk ratio, but maybe because of the software and all, they may give the odds ratio also. Okay, then what is the problem with using the odds ratio? Okay, we get a relative risk in the cohort. Okay, and in we get a odds ratio in the case control mainly, but can be calculated from the cross section also. But typically, practically speaking, when we talk about the odds ratio, it is harder to understand. Okay, human naturally understand the risk better than the odds. That is what is the human tendency. Okay, then not only that, it exaggerates the effect size, as we have already seen that the odds ratio for a common disease is always higher than the relative risk. So it will always exaggerate the effect size, especially when the outcome is common. Okay, for common outcome, you will have a high odds ratio, and relative risk will be less. So relative risk of 2.27, but odds ratio will be 6. So this odds ratio is apparently appearing higher. Okay, so what are the advantages of the cross-section study? It is fast, it is cheap, no follow-up is required, it estimates the prevalence, useful for public health surveys, it can study multiple exposure and the outcomes, which is a disadvantage with the cohort study. Okay. However, you get the multiple outcomes in the cohort. Okay, because you are following the same for over a period of time, but multiple exposures we are not getting. Okay, so disadvantages of the cross-section study: it cannot determine the temporal relationship, it cannot measure the incidence, cannot calculate the relative risk, it is poor for the rare diseases and prone for the prevalence incidence bias. Okay, so take home message for this is cross-section study is a snapshot study, exposure and the disease measured simultaneously. It uses the prevalent cases, calculates the prevalence, calculates the odds ratio equal to AD upon BC. Null value for odds ratio is 1. It cannot establish the causality. Okay, cause effect relationship cannot be established by the cross-section study. It cannot calculate the incidence, cannot calculate the relative risk. Odds ratio will approximate relative risk only when the disease is rare, less than 5% prevalence. Okay, so that finishes the today's topic of both cohort study as well as cross-section study. We have few questions, Dr.
Yes, sir. Question number 3: which measure is most commonly calculated in cross-sectional study? A relative risk, B risk ratio, C hazard ratio, D odds ratio, and E incidence rate. So D odds ratio.
Odds ratio, but best will be the prevalence, because odds is a typical for a case control. Remember, okay?
Yes, sir. Yes, sir.
So cross-section studies use prevalent cases, and therefore it can calculate the odds ratio also. Next.
Question number 4: which statement regarding cohort study is true? A follow-up is not required. A follow-up is not required. B disease is present in all participants at the baseline. C incidence can be measured. D only prevalence can be measured, and E RR cannot be calculated. So true, it is the incidence can be measured. So answer C.
Yes, yes. Such type of questions you are going to get. Cohort studies begin with the disease-free individuals and follow them up over a period of time, allowing incidence measurement. Next.
Question number 6. In a cohort study, all participants should be A. Disease, B. Exposed, C. Disease free, D. Unexposed, and E. Hospitalized. So it is disease free. C.
Yes, we begin with the disease-free in cohort. Okay, incidence measures new cases. The participant must be disease-free initially. Next.
Question number 7. A null value for risk ratio is A0, B 0.5, C 1, D 2, and E 100. So answer is C 1.
Yes, risk ratio is null value will be 1 for risk ratio. RR1 indicates identical incidence in the exposed and unexposed group. Next.
The null value for odds ratio is A0, B is 0.5, C 1, D 2, E 100. So answer C 1.
Correct. Again, same. Okay, or means no association. Next.
Question number 9. A study uses hospital record from the 2015 to determine smoking status and subsequent development of lung cancer by 2025. This is a cross-sectional study, perspective study, retrospective cohort, case control, and RCT. So it is retrospective cohort.
Yes,
C.
retrospective cohort because it begins in the 2015 and it ends in 2025, though the study is conducted in 2025. Okay, so it is a
Yes.
retrospective cohort. Okay, because we have gone retrospectively but collected data prospectively. Okay, from
Yes.
2015 onwards till now. Okay, we are ultimately following them from 2015. Okay. So exposure and outcome have already occurred and are reconstructed from the existing record. Next.
Which study is best for investigating the rare exposure? A cross-sectional, B case control, C cohort, D ecological, and E case series. So answer is C cohort.
Yes, remember. Okay, cohort. This is a very typical question. Cohort studies are particularly useful for rare exposure. Yes.
Which study is yes, sir. Which study is generally not suitable for rare disease? A case control, B cohort, C case series, D registry study, and E surveillance study. So not ideal for rare disease. It is the cohort study.
Again, cohort. Okay. So large population and long follow-up are required to capture the enough cases. Okay. Next.
Question number 12. Which statement about the cross-sectional study is true? A. Incidence can be calculated. B. Follow-up is required. C. Disease and exposure are measured simultaneously. D. RR is calculated. And E. Disease-free participants are selected. So C. Disease and exposures are measured simultaneously.
Correct. Correct. In cross-section, we measure both. Next.
Question number 13. Which measure is obtained directly from the cross-sectional area study? A. Incidence, B. Prevalence, C. Survival, D. Hazardous, and E. Mortality rate. So answer is B. Prevalence.
Prevalence, also called as these cross-sectional studies are also called as prevalence studies. Okay, cross-sectional studies will measure prevalence. Next.
Question number 14. Which study design establishes temporal relationship best? A. Cross-sectional, B. Ecological, C. Cohort, D. Case series, E. Audit. Sir, it is cohort.
Correct. So temporal association can be calculated. Next.
Question number 15. A researcher measures obesity and hypertension in 1,000 women attending clinic today. Which study it is? A. Cohort, B. RCT, C. Cross-sectional, D. Case control, and E. Ecological. Sir, it is cross-sectional
Yes,
study.
it is done at one point. You got both. Okay, exposure and disease are measured simultaneously. SSM. Next.
A cohort study reports RR is equal to 3. What does this mean? A. No association. B. Risk is 3 times as high as exposed individual. C. Disease risk is 300%. D. Disease prevalence is 3%. And E. Exposure prevalence is 3 times higher. Sir, B. Disease risk is 3 times as high
Yeah,
in exposed individual.
risk is 3 times high in the exposed individuals. Okay, RR compares incidence in the exposed and unexposed. Next.
A cohort study report RR is equal to 0.5 interprets the exposure doubles risk, no association, exposure half risk, this is absent, and exposure prevalence is 50%. Sir, see, exposure half risk.
That means it is a protective actually. Okay, so RR less than 1 suggests a protective effect. Next.
Using the table, exposed with disease is 40, exposed without disease is 60, unexposed with disease is 20, unexposed without disease is 40. What is the incidence among the exposed?
Incidence formula.
Incidence formula, new cases upon population at risk.
So what is the answer here? What is the question? What is the incidence among the exposed? Okay.
Exposed. So 40 upon 40 plus 20.
That is what I was again saying in my session, that please do not confuse this incidence along with the odds ratio. Okay, so here A upon A plus B, this is the exposed total. 40 plus 60 will be 100 total. Okay, so we have to calculate in the exposed. Total exposed are 100. Okay, total exposed are 100. Okay, so 40 upon 100 will be the incidence in the exposed group. Okay, you got it?
Yes, sir. Yes, sir. Yes, sir.
So 40% here. Okay, it is a very simple calculation, but just be alert. Okay, now using the same table, incidence among the unexposed.
So it is 60.
How come 60?
No, sir. No, not 60.
Now they are asking about the incidence
80
among the unexposed. So this is the unexposed group. So disease are 20
yes, sir.
and total are 20 plus 80,
80%.
100. So 20 divided by 100, it is 20%.
Yes. 20%.
Okay.
Yes, sir.
Diseased, here they are 20, here they are 40, and here total is 100, here also total is 100. So incidence here is a 40%, incidence here is a 20%. Okay, you got it?
Okay, sir. Yes,
So
sir.
we,
Yes, I got it.
so that is why
Yes,
I
sir.
said A upon A plus B, C upon C plus D is the incidence. Okay, right?
Yes, sir. Yes, sir.
So 20 upon 20 plus 80. Next. Now using the same table, you have to calculate the relative risk. Okay. Now relative risk. That
AD
is the,
upon DC.
that is odds ratio,
That is
doctor. Odds ratio. What you said is a odds ratio. Relative risk is the incidence among
risk
exposed.
exposed upon incidence upon non-exposed.
You got it. And
Yes, sir.
you get incidence in the cohort study. Okay. Okay,
Yes,
so
sir.
these all things you have to correlate. So it is now they are asking the relative risk. So relative risk is the incidence among exposed, which we calculated 40% divided by incidence among unexposed, that was at 20%. So it will come
20%.
40% upon 20%, it will be 2. And what is the meaning of
2.
relative risk? The risk is twice as
Risk is
high in
twice
the
as high amount of
exposed
exposed.
person. Okay, okay, now this is the table.
Yes, sir.
Now you calculate the odds ratio. Odds ratio formula.
This is among, sir, it is the incidence exposed upon unexposed.
Is it incidence, odds ratio? Odds ratio is not incidence among the exposed, and odds ratio is odds in the exposed divided by odds. AD upon BC.
AD
Okay.
upon BC.
Okay.
Yes, sir.
Here odds in the
Yes, sir.
exposed. That is what again I will say. See, odds in the exposed is 30 divided by 70. Odds in the unexposed is
Yes,
10 divided by 90.
10 divided by 90.
While when you calculate the incidence, 30 divided by 30 plus 70. Okay, that is incidence in the
Yes, sir.
exposed. You got it? And at the
Yes,
end,
sir, I
in
got
the
it.
session, session, what we mentioned, odds ratio is higher than the relative risk, because in
Relative
the
risk.
odds ratio we are just saying 30 divided by 70 that will come in the odds of exposed. But if you want to calculate the relative risk, you will calculate 30 divided by 70 plus 30, that is 30%. So your denominator is increasing here, so value will come down. No, you got it? So now what
Yes,
will be the odds ratio here? AD into
so
BC.
answer is 3.86, sir.
Yes, yes. It will be near about 4, so it is 3.86. AD upon BC. Okay, next.
Sir, which formula correctly calculates odds ratio? A upon A plus B C upon C plus D, C AD upon BC, D BC upon AD, E A plus C upon A plus B plus C plus D. Sir, answer is C, AD plus BC.
AD upon BC. Okay, yeah, AD upon.
Which formula calculates the prevalence? A upon A plus B C upon C plus D, C AD upon BC, D A plus C upon A plus B plus C plus D, and E is equal to E A upon A plus C. So answer is D, A plus C upon A plus B plus C plus D.
Correct. So it is the total disease in the total population. Okay, so total disease is A plus C. Okay, next.
Question number 4. When disease prevalence is less than 5%, OR is much larger than RR. RR equals 0. RR approximate OR approximate RR. RR approximate prevalence. OR becomes invalid. Sir, it is OR is equal to RR.
Yes. So option C.
C.
OR will approximate RR. Okay.
RR.
So almost equal to RR. Okay. So for rare diseases, OR is close approximation of RR. Okay. Next.
RR. Question number 25. Why can incidence not be calculated in a cross-sectional study? A, disease is absent. B, exposure is unknown. C, there is no follow-up. D, participant is randomized. E, outcome is rare. So disease is absent.
No. Cross-sectional, you have the disease, no? Cross-section. Okay. Because cross-section you are doing not doing the follow-up. No, incidence requires time unit. No, here there is no follow-up. Okay, so you will not get the incidence in the cross-section. Okay, so option is C. Incidence requires observation of new cases over time. So cross-section studies do not include follow-up and therefore cannot measure the incidence. Okay, so that finishes the today's topic of study designs. Thank you.